Hi, everyone. My name is Preston Dotsey. I am a senior and I'm actually just about to graduate this term, so I'm very excited right now. My partner is Pankaj Behera. We made this project together, but unfortunately his voice is kind of giving out on him right now, so I'm taking over the narration duties for this. So between the two options that we had for doing the mini project, we were thinking about doing the exploring of like rewriting some code to like still incorporate concepts that we've been learning about this term, but actually looked at the other option of looking into an existing framework that uses a lot of these concepts as well. And a few of them like really caught my eye. The one that caught my eye the most though is Lift framework. So I decided to dig in a little bit deeper into that and explore how it actually uses a lot of the concepts we've been talking about in this class out in industry. So on the agenda, I'm going to talk a little bit about the background of Lyft and like how it got started and what it's trying to accomplish. Um, the three main points I'm going to go over are abstract data types, high order functions, and functions as values. The Lyft framework shows these three concepts throughout most of their code, so it's actually a great example to use for this. So I'm excited to show you a little bit about it. Okay, so first off with background, what is Lyft? So Lyft is a free and open source web framework that's designed for the Scala programming language. The whole thing is entirely written in Scala, and that was designed so that it could be portable to any Java virtual machine and run with any hardware, other existing frameworks. It's meant to be like a plug and play kind of thing. It was originally created by David Pollock, who's dissatisfied with certain aspects of the Ruby on Rails framework. I know that like through my reading of it, he definitely drew a lot of inspiration from it, but there was some things that he thought could have been done better, and so he decided to go in a different direction from it. Lyft was launched as an open source project on the 26th of February 2007, and it was actually licensed under the Apache license. An example of the framework commercial use is Foursquare, which I don't know if you know what Foursquare is, but it's a cloud-based location tech that basically lets customers and businesses become aware of each other like through their phone. When it uses like geospatial data to tell you like which customers are close to you, what businesses are close to you, and it's become quite successful. But that was their first major commercial application of Lyft. And so as a framework, it is specifically designed to write web applications. Like I was saying earlier, it's very similar to Ruby and Rails. The reason why it's similar is that it favors convention over configuration. But the main difference between them is that Lyft is designed with a view first architectural pattern, and Ruby on Rails uses the model view controller pattern that a lot of other frameworks use. And so it's a little bit of a deviation from that. The use of view first is intended to make the development more designer friendly, which is inspired by the Wicked main framework. So what is Lyft actually meant to do? So according to the website and looking into it, he had 5 core tenets that he really wanted to incorporate into Lyft. So he wanted to be designer friendly. He wanted to be really fast and efficient. It wanted to be secure, especially against like online attacks from other malicious users, easily scalable to handle lots of web traffic, and easily extractable. And so it has to do with security as well. He really wanted to abstract a lot of the data away from the user and instead rely on functions in the background which communicate with the front end. All right, and so how do they actually accomplish these goals, and how does it relate to our class that we've been currently taking? So the Lyft framework owes its ability to accomplish its goals through its incorporation of several key concepts, which we have learned about over the course of the semester in 3155, namely abstraction and data types, which relates to security, use of higher order functions, which, as you'll see in a little bit, are everywhere in web applications, and treating functions as values, which is something that we have heard over and over and over again. But actually, through exploring this, it helped really sink that idea in a little deeper. All right, so first, abstract data types. So let's go over what abstract data type actually is. For the sake of brevity, I'll call it ADT from here on out. So an ADT is a type or class for objects whose behavior is defined by a set of values and a set of operations. The definition of ADT only mentions what operations are to be performed, but not how these operations will be implemented. So it's very similar. I've been doing a lot of Java lately, and abstract classes are used all the time in that class. It does not specify how data will be organized in memory and what algorithms will be used for implementing the operations. And the reason why it's called abstract is because it gives an implementation independent view. So it's abstracted away from the actual guts of how it works. It just gives you a definition, which you can use in other parts of your code. All right, and then how do we use abstract data types in this class? So ADTs are used heavily throughout the labs, as you probably have seen. ADTs are especially prevalent in the ast.scala files, which I found in them. The abstract syntax trees use a ton of abstract classes within them. And yeah, so a good way of thinking about it is that in the AST objects, they declare the classes, but they never actually show what they do, because we ourselves are actually the ones implementing those in our like lab.scala files. Instead of implementing the methods of the abstract classes in the classes themselves, we have implemented the class methods within the lab Scala files, as I previously said, and the objects then communicate with each other to carry out their functions. By incorporating this abstraction into our lab files, we're able to increase the ease at which we make changes to methods, hide private data, increase clarity within the code, and make our code more secure by hiding key details. All right, so as an example of that, I actually took a little bit of code out of the ast.scala file from lab 4. So in this, you can see right here that it's a sealed abstract class UOP. And so and you can actually see down below, there's the BOP one too, but I use the UOP just because it had a more concise example. So in that we have neg and not. And here we go. You can see, so in this right here, we're defining it in an abstract class, but we don't actually see what it does yet. And so if you look into the lab4.scala file, I looked into the function type of, and you can see here, we have both unary and neg actually implementing everything and like laying out how the guts of it work. So in this, we get an actual definition that we can use in other areas, but it pulls from this implementation. And so by splitting it into different objects, you're able to allow the objects to just communicate with each other instead of having it be like a monolithic, like huge class with everything all together in it. So this increases security. It makes things simpler to debug, honestly. And through a lot of my classes lately, I've been realizing that if you're doing an object-oriented language, creating lots of smaller objects that all talk to each other is so much simpler in the long run than creating these huge files all at once. And so Lift also uses ADTs as well. I'm realizing most web frameworks actually use a ton of all these concepts that we've talked about. But the most obvious use of ADTs with the Lift framework is how it abstracts away their HTTP requests. And so instead of having it all carried out on the front end, it actually abstracts it away to backend servers that hold the implementations. So it calls it using abstract data types, but the actual implementation carries it out on the backside. So there's no user-facing implementation at all. And so I lifted a little excerpt away from their site. And so Lift at its core seeks to abstract the HTTP request response cycle rather than placing object wrappers around the HTTP requests. By incorporating this abstraction into their lab files, they can increase the ease at which they make changes to methods, hide private data, increase clarity within the code, and make their code more secure by hiding key details. And so I actually have been referencing the Lift handbook for a lot of the code examples on this. And so I have an example here of how it does that. And so as you can see, there is no actual implementation done. It just has these abstract classes that are called on the front end, and then it will actually send a request to the server, which carries out the functionality of it. Oh, sorry, that's a copy of that. And on to higher order functions. So first, let's define what a higher order function is. And so in computer science, also mathematics as well, but we're talking about computer science right now. A higher order function, or an HOF, is a function that does at least one of the following. So it takes one or more functions as arguments or parameters, whatever you want to call them, or it also returns a function as a result. So it doesn't have to do both of them, but it just needs to carry out one of those requirements. And so how do we use this in our class? So higher order functions are one of the most important concepts we covered this semester. With the use of higher order functions, we are able to incorporate another layer of abstraction into our code and introduce a layer of separation between our classes. Higher order functions also allow us to use the return values from the functions called within the HOS parameters in a streamlined and easy to parse manner. By incorporating HOS, we are also able to facilitate the function to facilitate function composition, which is essentially composing new functions out of multiple other functions. This is possible due to the fact that Scala treats functions as first-class values. So that's a very important point, and we'll touch on that more in a little bit. So as an example, I pulled this from the lab5.scala file. And so it is the first map width that occurs in there. And so as you can see, it only has one case within it, case DWBS. So the first function in that call is actually flat map, but within the parameters, we also have a map as well. So it's a function that's calling another function within it. And so instead of having everything like laid out in the open, it's just calling another functionality from the library. And then that value that's returned from it is used within the first function. So map returns a value or a series of values, and then flat map works on those afterwards. And then, so let's look at how lift also uses high order functions. So lift heavily relies on HLFs as well. The entire framework is written in Scala, and as such, uses the same libraries that we have used in 3155. So you'll see a lot of very similar code all throughout lift's code base, as we've been using in 3155. Yeah, Scala is, through a lot of my research, it seems very good at scaling. So it's very popular in a lot of web frameworks because it's compatibility with Java and its ability to scale up very well. In the building of web applications with Lift, many HOFs are used to facilitate the functionality of the same applications. Common HOFs used in the Lift framework include map, flat map, and filter, which I think you're probably pretty familiar with those by now. Common uses of these HOFs are in the organizing and listing of user data and retrieving internal data from the application's backend. And so I also pulled this from the handbook as well. So this is another good example of a high order function. So as you can see in the case class, down at the bottom, you have the S2, it calls function full, but then within that, we also have param infos, which is another function that it's calling on itself. So it's very similar to what we were seeing in class. Most code snippets that I saw within the book contained higher order functions. All right, last topic, functions as values. So Professor Chang has said this over and over and over again, but I'm going to just give it a quick recap of what he means by that. When we say functions are values, this concept is one of the defining features of a functional programming language. All functional programming languages have this concept as a core tenet of how these languages execute. The idea behind functions or values is that functions are not separate from the values they return, but rather are the values themselves. By treating the functions themselves as values, we can now use functions as parameters within higher order functions. So it loops back into higher order functions also as well. This allows us to create cleaner and more efficient code, as well as increase abstraction and rely more heavily on the communication between objects instead of making monolithic classes, which are much harder to debug than a collection of smaller objects that cooperate. And so how does functions as values fit into what we've been learning about in 3155? Obviously, Professor Chang has said this over and over again. She really tried to drill it into our heads. Incorporating this concept into how we think about functional programming has been vital to creating solutions to our assignments this semester, especially when writing code for the lab assignments. In our labs, we've been using many higher order functions. The reason why we can use the parameter functions within higher order functions is that in Scala, functions are treated themselves as first-class values. That means that when we pass a function to another function, we're not actually passing the function's details to the HOF, but rather passing the value that the function itself represents. And down at the bottom, just another reminder that the reason why this works is because functions are values. So I pulled an example from, which one was it? The lab4.scala file. And so I chose fold left for this one instead. I thought this was a good example of it because fold left actually incorporates another function loop. And then in case node LDR, it calls loop again, which within loop calls loop. And so it's a higher order function that is treating loop as a value within the higher order function's parameters. And so this would not work if it did not treat functions as values, because it wouldn't know what to make of it. So it's able to parse through the result and actually see it as a value. And you see this over and over and over again in the class. It's been drilled into our heads because it's a thing that it's like fundamental to what makes functional programming actually work. And then let's go into Lift and how they use it. So just as we have used functions as values in our lab assignments in 3155, Lift also follows this concept and its framework through its use of Scala higher order functions. Practically all web application frameworks make heavy use of HLFs, which can only execute if the functions in the HLF parameters are treated as values. Lyft takes advantage of this concept to use functions as values within HOF parameters to facilitate simpler code implementation, ensure code security when deployed to clients, and allow developers to use the Scala libraries, which make their framework run smoothly. And so this was also pulled from the handbook as well. I thought this was a great example of it because it actually has 3 high order functions in a row. And so it's converting the return value of these higher order functions into a result, and then performing more higher order functions as well. So it's basically like 3 nested higher order functions within themselves. And the reason why they can do that is because it's actually treating them as values and not as functions. All right, so quick summary. I'm running out of time right now, but the use of ADTs aren't just a thought exercise that we use in class, but they're super integral into part of building web applications and other pieces of technology. Lyft framework is no exception and uses this to their benefit as well. Higher order functions are also ubiquitous when working in functional programming languages. Like, we've talked about them a lot in this class, but I didn't realize how much of a great degree they're actually going to be out in industry. Like, looking through all these frameworks, higher order functions are everywhere. Almost every little function that I've seen has been a higher order function if it's doing anything more than just like assigning a value. And then the last point, functions are values. And the reason why this has been repeated so much in this course is that if in functional programming languages, if it wasn't treated as a value, the way that these languages work wouldn't work anymore. Like, if higher order functions didn't exist, which they wouldn't without functions being treated as values, most other parts of the language become crippled. And so that is the very base layer of how everything works in this. All right, thank you for watching. I'm sorry I'm a couple minutes over, but I really appreciate it. So for me and Pankaj, good luck with all of your finals, and thank you for having a great class. All right, see you guys.